Hello, everybody, and welcome to another wonderful day of chemistry. So today we're going to be looking at that great goal that every good chemist is looking for, good yield, which is more or less a way of talking about trying to figure out how much product you can produce and, well, the lesser number, how much you actually did produce. So for that, we first need to go ahead and revisit stoichiometry. So again, one of the big parts about chemical reactivity is we have a general chemical reaction, and we need to relate how much I fed in, how much reactant I fed in, and how much product I produced, and looking at the ratio of these two. So one of the big parts of chemical reactions is looking at these stoichiometric coefficients and that stoichiometric ratio. So if I have A moles of A, how many moles of C did I produce? And this ratio is defined by the chemical reaction and our stoichiometric coefficients, in this case, lowercase a and c. And these ratios, as we've already seen, can be used to determine exactly how much reagent I need in order to perform a reaction, or more specifically, what's the maximum amount of product I can produce if I have a given amount of starting material. And this second objective actually has its own name. It's called the theoretical yield. So it's trying to figure out the maximum amount of product that can be produced. So if everything went perfect, how much product can I generate? So let's go, and we already know the basic mechanics of how we can use stoichiometry to generate this. So let's go ahead and try and figure out the theoretical yield of one of the reactions we've looked at so far. If I mix zinc solid with hydrochloric acid, how much H2 can I produce? So what happens if I put in 100 grams of zinc with plenty of acid? Well, I can go ahead and set up my unit analysis, turn grams of zinc to moles of zinc, moles of zinc to moles of H2, and moles of H2 to the mass of H2 generated. And let me tell you, this will be a little bit disappointing because zinc is relatively heavy and hydrogen gas is relatively light. So if you end up putting in 100 grams of solid zinc, you produce about 3 grams of hydrogen gas. Not exactly great gonzos. But this is the maximum amount you can generate. In reality, you never produce the theoretical yield because nothing's ever perfect. We can hope, we can sometimes get pretty close. So the number that often people like to report is percent yield. So if I can produce a given amount, what percentage of that, or how close to perfect am I? So it's almost always lower, the percent yield is almost always lower than the theoretical yield. If it isn't, it usually means you didn't account for something. There was some extra reactant, or you did a very bad job of measuring your product. For example, it may be wet, you forgot to include the water. But if things are actually going as they should, percent yield should be less than 100%. And it can simply be calculated as how much you actually generated divided by how much you theoretically could generate. So let's say I react my 100 grams of zinc, I produce 1 gram of hydrogen. What would be my percent yield? So for that, I can make use of my theoretical yield of hydrogen. And it turns out this would be about a 33% yield. So this is one of those numbers that we're often after. But here's part of the problem. We assumed that I had plenty of hydrochloric acid. Well, what if I don't? How can I tell whether or not zinc is going to determine how much H2 I produce, or whether or not it's going to be the hydrochloric acid? So for that, we're going to hit that topic next time when we look at limiting reagents. Until then, take care.